Hello everyone, I am Matsuda from OA Development 1 team, and my presentation is a development process refactoring. In this session, I will be introducing the process improvement that was performed in the server-side development team. We focused on the development process, especially repository management and the report review processes to make improvement, because the quick feedback and also the small and quick improvement would result in the improving the development throughput. As a result, the pull request merge time reduced by 89%, and in the qualitative survey, it was mentioned that the development speed has accelerated. And today, I would like to introduce the refactoring that was performed within the team I belong to. Before I do that, let me briefly introduce the team I belong to. Manager line biz is the domain, and we are using that domain to develop the CMS contents management system for official account. When you hear about the CMS, you might think that this is the background or back-end simple system to just store the data such as the articles. But when we say CMS, it's more complicated. It is developing the line from the perspective of the official account. For example, you can't see the individual's name, but this is the friend list viewed from the official account. For example, your official account has the 10 million friends. Of that, 6 million is female, and also how many of them have visited your own site. Those information is managed. And the second, you can send them messages, or you can create the coupon to be attached to the messages, and also you can create a different content such as the stamp card, the sticker card for users. When the messages are sent, you can check whether the messages are read and whether they are purchased any product on your site. So those metrics are gathered. You can understand the situation of the friends, and the messages are sent and analyzed and reflect those to the next actions. So CMS can enable such processes, and also it has the payment feature to use the official account, and also the data can be integrated with the internal services that uses official account. In terms of the server configuration, we have about the 20 microservices and servers internally, and we have about the 300 virtual machine and the physical machine in terms of the server number. That's the product. And for the development members, this time we are focusing on the server-side engineers, but we have the group called the unit of 4 people by function, and each unit is responsible for the closed responsibility of the specific scope. So we have about the 13 core developers, and the code-based change speed-wise, the monthly pull request is 248. So that was a brief introduction of team. The team of 13 is not a small team, but it doesn't mean that we have the multiple small teams. So it's like we have the invisible wall, and if we want to grow the team, then we may face the insufficiency or inefficiency. You may have had the similar experiences. We think that we need to grow this team bigger, and that requires human resource structures, and other than that, engineering type of the improvement are necessary. That's why we have gone through this improvement process that we are covering here. And this is what we are going to talk about. First, I will explain about what we mean by the refactoring, and after that, I will introduce and what we did, and then I will wrap up as a summary at the end. First, this refactoring in our own term is as follows. We think that there are 2 types of refactoring. One is a general refactoring. Without changing the functionality, it just increases the maintenance ability of code. Another important point is the refactoring of the development process. And in this session, we will focus on the latter case. Now, let me explain about how we made and what kind of development process improvement we made. And there are 3 process improvements I'd like to introduce from left to right. We changed the size of the Git repository and the branch management method and code review approach. So when you hear this session, you might think that this is what you are doing in your team, or if you can find this something useful to be introduced into your team. Then first is the size of the Git repository. Line uses the microservices. Each module uses the API communication to provide the services. Repository management method was creating the repository by microservice and module in the past. The role and the engineer's responsibility was clearer by repository. However, today we have one big repository, and the microservices and the common modules are represented by directly, and all members commit to that. Why is that? When we have the multiple repositories, we faced some problems. When you have the split modules, then the pull request and the review is necessary for each feature implementation. So let's use the slide as an example. From the manager line biz that user access, from there you have to call the another API service internally, and in that case there are some dependencies, and this functionality development requires 3 changes. One is the domain model protocol stack needs to be updated for calling the API. Second is that you need to implement the internal API to be able to return the values for the new functionality through API. And the third is on the manager line biz side, API needs to be called out, and based on the information from the internal API, user needs to be provided with each features, and the branch rules and the deploy style are different by repository, and at least the 3 reviews are necessary, and also the coding style CI tools are different by repository, and also the dependency library version may be different. And we think that these issues are attributable to the separating the repository. That's why we integrate the repository, and inside the repository there are directories to represent everything else. So directory is used to represent instead of the repository to show the module, and the engineer's mindset changed. In the past, we may found the better way to split the layers or the scope, but after some comprehensive judgment, we didn't do that in most cases, because you need to have some maintenance by setting the CI, and there is a cost to create a new repository, and the reviewer needed to go to that particular repository for review. Those costs incur. So thinking about that, they may be functionally split, but it was limited that where we can separate the module. And based on such potential cost, we need to clean the architecture to prevent the technological degradation and create the repository. But if we have the different repository, then the review or library update maintenance may not be up to date, and the refactoring doesn't proceed. And the different directory and the same repository can represent a module. That means the engineer can create the directory and move it. And if it's good, then they split module, and if it's too much, then they can integrate them. With the change history, the engineers can naturally do that. When the module is updated, then the code that uses that module is in the next to this directly, so it's easier to test. So in the past, you need to update the module, and after the unit test and the users update the module, then the unit test didn't pass, so they had to update the module again. But if we have everything in one repository, then it doesn't happen. So let me summarize the repository management. By having the single repository, we are able to reduce the unnecessary work, and we are able to efficiently develop. And the server side has the 13 members in the team, and we think we can still scale. And we are still just using the one repository per team, but the big IT company like Google, they use the single repository across the company, and they have publicized a document that summarizes their insight, and we have referred to that. If you are interested, please refer to that document. And next is a branch management. If you faced some issues of the Git branches, and have you tried the different flows? Yes, actually, we have experienced the different operation rules. For the branch management, we had a very typical interaction to change our awareness. One day, we received this message on the Slack. Internal test environment isn't working. Can someone please check it? This is often thought this is the very common issue, but there is a very interesting point. It didn't scale. So server-side engineer, the number of server-side engineer increased. Then that means oftentimes that the QA or front end actually point out the issues. Well, normally it's other way around. If we have 10 times more people, then of course that the changes would be made 10 times more, so it may be easy to break. However, we have 10 times more people. That means the people in the server-side team should notice. The cause was very simple. The server-side developers didn't really develop on the development branch, which is the development environment. So this was our traditional operation. There is the one branch, mainline branch called master, and this content is already confirmed. It's very close to the released version, and this is the starting point for change. Another one is another internal development branch called develop sandbox or beta, and this is expected to be synchronized with the internal environment.
Development start development as follows. Development branch, including changes, are created from mainline and they are merged to development branch and tested. However, in this operation, the end of the mainline and development will be different as time passes. It is just like the case that developers are looking at code on mainline, but the results will be different when all the features are merged. When the size of a repository is small, it is okay, but as the size grows, different views among departments and members will be an obstacle in team management. The biggest issue for our case is that while server-side engineers are looking at the top of the mainline, front-end engineers are looking at the tip of development branch. There are two ways to think about this problem. First, give up joint management and set up different teams and repositories. But we knew that this does not work sometimes. Therefore, we decided to change the way to manage branch, keeping repository single. I mentioned it already. Management of multiple versions and branches maintaining each of the latest state is too difficult. There will be many issues expected in the management if we have a gap between mainline and development. If we accept the state that the latest version for total team and latest version for each engineers are different or unrelated, code-based management will be difficult. Latest version for each engineer in the team looks different from the latest version other teams can see. It was the cause of the comment from other teams I mentioned at the beginning. This makes management among multiple teams difficult. We try to solve this, not to avoid this, by further dividing up teams and repositories. As a way, we eliminated development branch and set up a single truth of mainline. The end of the mainline where you start development is the target branch merged after review, and this is deployed in-house test environment and corresponds to the next release candidate. This is a summary slide for repository and branch. We stopped creating multiple repositories and instead decided to use directories instead. We used multiple repositories because this is good for management. However, giving up this made us easier to check and manage codes. We decided not to split branches and stopped creating the following 4 branches. They are new feature starting point, merge destination, internal test environment, release environment. The third theme is about review. In our case, code review is a bottleneck like other development teams. When there is a bottleneck, team's throughput slows down and does not usually improve even with some measures for improvement. We know about that, but we are not able to change the situation. Although there are many detailed methods we can think about, but we firstly agreed to prioritize reviews. But we did not want to end up with the creation of a catchy word, so we made up a checklist. Number 1, did you finish code review requests from your teammates before you start coding? Number 2, do you subscribe code review request notification in emails and Slack? Number 3, do you check review requests regularly like you do for Slack? There is always a comment we receive when we ask speedy feedback to request, especially when we insist review first. Pending review request does not matter because code is released in the end. I review after I receive multiple requests since my interruption cost is higher than the benefit of faster feedback for peers. Responding that, we think interruption is not the only cost to consider to balance the cost of delaying feedback. Pull request is just like the code inventory, not delivered to users. If you keep piling up the stock saying that this will end up in sales, as a team, cost spent to create those stacks will be kept forever. In IT industries, if review is not timely, you sometimes cannot receive feedback from users, and there will be a cost increase to resolve conflict. Based on such concept, we decided to decrease inventory as soon as possible so that we can quickly ship or release the code. We understand engineers definitely need time to completely concentrate, but we implemented policy to recommend checking reviews when you are interrupted by Slack and others. This chart shows one example of the result after review first is implemented. The graph shows a median from the time pull request was generated and to when merged or became a release candidate. Horizontal axis shows years from 2018 to 2020, and vertical axis shows median until merged. The time unit is hour. In 2019, the median was 26.1 hours. In some months, the figure exceeded 100 hours more than 4 days. The change can include minor typo fix and refactoring, as well as the major feature addition. So it's hard to estimate, but based on the experience, I feel standard refactoring is processed in these hours. In 2020, the median decreased to 2.9 hours. That was a reduction of 89% in figures. the biggest benefit of reduced review hours is the change of mindset for review. In the past, code review was something you must do but don't want to. So feedback is returned when you forgot what you requested, and this slowed down the development process. We saw many such negative cases. But quick code review allow you to receive feedback while you still have a clear memory about the code you wrote in concentration. There will be more discoveries from your teammate, and the cost to incorporate the request is low. Review summary. We executed review first and were able to speed up feedback. Of course, this will be a load to individual engineers, but making effort to improve each other's throughput, your task speed gets also accelerated. Such feedback loop was produced. Then let me summarize this session. At the beginning, I said that there are two types of refactoring, followed by the topic of process refactoring, especially focused on the following three: repository, branch, review. In the end, while I look back each of this point, let me introduce the voice from team members when we asked how they felt about these three. First is about refactoring. In this presentation, I focused on improvement by eliminating the waste in process. Both are important, but quick feedback through process improvement will make code refactoring easy. Second, repositories and branches. In order to make a team scalable, we intentionally adopted a simple method: one repository and one branch. As for repository, we stopped using multiple repositories and used directories instead on one repository. We revised branch operation rules so that we focus on one special mainline branch. About review. We made a fundamental policy review first. We made a checklist so that we start writing our code after finishing code reviews requested. Actually, wait time for the feedback is largely reduced in figures. Such reduction spent in review time generated trust among team members, and we found review is not must-do, but submitting review quickly is the fastest way to receive feedback from your teammates. We gave questionnaires to our team members how they felt about this year in the preparation of this presentation. I cannot cover all the voice, but let me pick up some of them. If you have similar challenges like the ones introduced here, this might be a nice opportunity to start thinking about the deployment of what I said in this session. The first benefit pointed out was quick review leads to quick release, which made scheduling easier. Before, there was a case that although the code is completed, review is delayed and missed release this week, and this delayed the schedule for another feature that uses the feature above. Second voice. Conflict is reduced and many merge operation tasks are also reduced. We used to merge to development branch and re-merge to mainline when there are no issues. Such unnecessary operation is no longer required. In this operation, conflict occurrence is rather a good signal because we had issues like there were no conflict but we cannot compile after merge, or we compiled successfully but the result of the merge was not as we expected and found issues after releasing to production environment. It's good that we were able to reduce such cases. Another comment is context switching between coding and reviewing is not needed because version I refer to in code review for my teammate is similar to the version I am writing. About disadvantage, Based on our policy, we quickly incorporate unreleased features into mainline. They should be hidden to users. To hide such unreleased features, we need flags. It depends, but overall evaluation was positive because the status is easier to see than branch-based management. Thank you for your attention. This is the end of this session.